And let's go through these problems so that way you guys can be prepared for your test that you have next class. If you run into any questions, please feel free to message me either on Remind or you can send me an email. Remind is best because, it's a little bit faster and I'll know that I get it. But I will try to check and see if I have any emails as well. Also, I'm going to be in the building later on today and I'm going to be in the building tomorrow. So you can definitely come and see me with any questions too. All right. So for number one, we had to decide whether it was or was not a function. So the first thing we're going to ask ourselves is if we see any repeats for x, and we do. We see here and here that we have x is -3 and x is -3. We've discussed this in class that we're kind of visualizing in our head that this is almost like, I know there's points, but it's almost like a table, and they're plugging these values in for x, and then they're getting these values from y from an equation, because every type of equation that you guys have typically done has been a function. So it makes no sense in our heads that if we plug in -3 into the same equation twice, we're going to get two different answers. So that's why this is not a function. And we've also discussed in class that if we wanted this to be a function, not a function, we would take away this point. Either this point would not exist or it would have to say the exact same thing. So if we get -3, we get -2. If we get -3, we get -2. So the only way this would be a function is if we didn't have any repeaters for x. And by the way, we only care about x. We don't care about y repeating, only care about x. We look and see if x repeats. Then if it does, we see if it says two different things for y. If it says two different things for y, not a function. If it happened to be exactly the same point, then that would be okay. That would be like a little, different of a problem, but that would be okay. All right, so for number two, we have to list the domain and range. I apologize, I kind of wrote this. I moved things around because typically I do try to write it in order from least to greatest. I'm not saying you have to. I just tend to do that because makes me happy. Also, remember that in our domain and range, you do not have to repeat. So domain is going to be all your x values, your input values. Range is going to be all your y values, and you're going to list all of them. For number three, it asks which is not a function. So once again, we're checking to see if x repeats. So boom, 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 no repeaters. That is a function. Boom, boom, boom. Oh, whoa, whoa, whoa. We're repeating here, here, and here. It makes no sense at all that we get the same number plugged in and three different outputs, three different y's. So that is definitely the one that's not a function. But you can check the last one too. Boom, boom, boom. Three different x's. So we're good. That is a function. Okay, for 5 and 6, we're plugging in the value they give us. This is asking us to evaluate this function for f of 5. So we're going to go ahead, plug in 5 for x. Do not touch the left-hand side. We're only calculating on the right-hand side, and we're still following the order of operations. So we're going to go ahead and multiply. Then we're going to go ahead and subtract, and it is proper to write your answer like this. So f of 5 equals 65. For number 5, they asked us to do f of -1, so we're going to plug that in for x. Make sure you're performing the appropriate order of operations. I put this one in specifically because I wanted to make sure that you're not making any calculator mistakes. Remember, if you're plugging this in for x, you're going to want to put those parentheses. You want to put those parentheses also in your calculator because you're doing -1 x to the second power. X is -1. So a negative times a negative is a positive. So your exponent's coming first in this problem. Then we're going to do this multiplication here. And then it's just only subtraction or addition left, which would be from left to right. So 1 minus 4 is going to be -3, minus the 7 will be -10. So f of -1 equals -10. Okay, graphing. I told you guys, I'm sorry, if it's going to be multiple choice, you're going to see those graphs going by twos. If you don't like that, you go ahead and throw those little extra in-between lines if it makes you feel better when you're looking at the problem. So this one, awesome, in slope-intercept form. My slope happens to be -2/5. My y-intercept happens to be 1. Remember, the number in front of x is your slope. The number without the variable is your y-intercept when it's in this y equals mx plus b format. So we're going to start with our y-intercept. So we're going to start at 1, and then we're going to count down 2 units over 5 over to the right. We're always going to associate the negative with the numerator. So you're going to go down 2 over 5. It would not be down 2 back 5. That would be negative over negative, and a negative over a negative turns into a positive. So down 2 over 5. The graph that does that is graph B. Okay, for number 7, it's not in the right order for us to look at slope-intercept form. So we're going to go ahead and subtract x. Then we're going to go ahead and divide by -1. So now we have this nice equation. So our y-intercept is -1. Our slope is 1, or 1 over 1. So we're going to go ahead and start at -1. Neither of these even start at that coordinate. So I kind of went, nope, nope, but starts at -1 and goes up 1 over 1. So this is the appropriate graph, choice B again. For numbers 8 and 9, we're going to try to plug in to figure out what is the slope. So y2 minus y1 over x2 minus x1. Remember, if you're using your review sheet, you're going to want to have this written down. It doesn't matter which one you make your first and your second. I typically take them, in the order that they're given, unless there's some other reason why. So I did 20 minus 6. I did -12 minus -18. -8. The double negative turns into a positive. So that's how we got the +8 on the bottom. So I end up with 14 over -4. A positive divided by a negative will be a negative. So technically the whole term, the whole number is negative, although when we do calculations, we associate the negative with the numerator. And 14 over 4 will reduce to 4 over 2. Remember, if you have those graphing calculators, if you put the fraction in, the graphing calculator will simplify it for you if you're not sure if it's been simplified completely. For number 9, same thing. So we have 3 minus 8, -14 minus -14. Double negative turns into a positive. On the bottom, it ends up being 0. We went over it in class, and it's still on the board. If I have 0 on the bottom, we think of no and okay. N over O, I said no because we don't actually have a value. It can't be calculated, so it's going to be undefined. So if you put this in your calculator is going to give you an error message. It can't calculate this. This isn't a value. If I had a 0 on the top, we think of okay, and that would be okay. It's 0, but it is a value. For number 10, they want us to find the slope. I think the easiest way to do these problems is to count it out. So first off, it's going up from left to right, so we know it's positive. And remember, it's going to be the rise over the run. So from this point to this point, it goes up 5 squares, and it goes over 8 squares. So we have 5 over 8. Now, if it's something that can be reduced, don't forget to reduce it. For number 11, they want us to find the slope that's perpendicular to this equation. So the slope of this equation is 7 over 3, but we want a perpendicular slope. So that's going to be opposite reciprocal to this one. So since this is positive, the opposite will be negative. Since it's 7 over 3, the reciprocal will be 3 over 7. The only one that sometimes gets confusing is 1 because the reciprocal of 1 over 1 is 1 over 1. So just keep that in mind in case that happens. For number 12, they want us to decide whether it's parallel, perpendicular, or neither. I already went through perpendicular as opposite reciprocal. Parallel we know is the same, and neither means none of that going on. So you see me finding the slope for the first line. Here's the calculations. So it ends up being -4 over 6, but do not forget to reduce it. So it's -2 over 3. For the bottom one, you see me doing the calculations over here. This is 6 over 4. Again, do not forget to reduce it. So it's 3 over 2. One's negative, one's positive. One's 2 over 3, one's 3 over 2. They are perpendicular. On the quiz, a lot of people had mistakes with this problem because they did not reduce. Number 13. Write the equation in slope-intercept form. They give us the slope, they give us a point. When we write an equation in slope-intercept form, we want to fill in numbers for m and for b. Y and x gets left as variables. I know what m is, it's the slope here. I don't know what b is. What we're going to do temporarily is to plug these in for x and y, because that's what they are. This is the x coordinate, this is the y coordinate, to get the value for b. So we do this, we calculate it, we solve it, and we get b is 4. Now don't forget to write the final equation, y equals 3x plus 4. For number 14, we have to do the same thing, but we're given less information. So when I have 2 points, I want to find the slope. We found the slope and the problem's up above, y sub 2 minus y sub 1, x sub 2 minus x sub 1. So we're going to go ahead and do that. So I have negative 2 minus 1, 0 minus negative 1. Double negative turns to a positive. So I have negative 3 over positive 1, which is negative 3. You get to pick whichever point you want. I personally picked this point to plug in. So I have negative 3 times 0. And I have, that just kind of, turns into 0. So 0 plus b is just going to be b. So b is negative 2. So I actually ended up, they gave me the y-intercept. If you realize that and you were able to write that immediately, that's fine. If you plugged it in, no harm done. That's great. They don't always give you the y-intercept. It just happened to be that here. So that worked out nice. For number 15, we want to find the slope of a line. They give us a point. They tell us it's parallel to this. Remember above, we just said parallel means same slope. So technically, this that they're giving us here means, hey, the slope is 2. Use the same slope. So here I have slope. Here I have a point. So this is actually like the problem 2 above. So we're going to go ahead and plug in our point. We're going to plug in our slope and try to figure out what b is. In this case, we go ahead and we add 4 to the other side, and we get y equals 2x plus 4 as our final answer. All right, for number 16, we're going to go ahead and we're going to punch this in our calculator. Oh, no. All right, let me grab my calculator to do this. Let me see if I could get it up here. Would have been better if I had planned that out a little bit better. Sorry about that. Hey. Okay, it's taking a second to load. So sorry about that. So let's move this over to the side. And let's keep this up as well, but let's move this over to the side. So that way I could see both things at the same time. Sorry about that. All right, so I'm just going to clear it out. Second plus sign, 7, 1, 2. My apologies. In order to do these problems, the first thing we're going to do is we're going to hit stat. We're going to enter into edit, and we're going to put our data in there. So I have 1, I have 3, I have 5, I have 5 again, I have 6, I have 10. Okay, next row over, 760, 510, 310, 310, 210, whoops, sorry. And another 210. Okay. So once I do that, if all I care about is getting the equation, the next thing I'm going to do is hit stat. I'm going to go and arrow over to calc. I'm going to go to linear regression, which is number 4. I'm going to enter through this menu, and I'm going to get this. So I would write y equals negative 60.9x plus 689.3. I told you round with your heart. If you want to see the graph, I know most people are just going to do this by hand, so I have it there. But if you wanted to see the graph, you would just hit second, y equals. We're going to turn it on to graph points because the default has it off. Now, technically, the graph is there if I graph it. It's just our window is not big enough to see it because it's a 10 by 10 window. So my X max is okay because X max goes to 10 here. But I do need to change my Y max to at least 760. So maybe I'll do 800. And there's my graph. So just in case you wanted to see that. All right, there we go. Sorry about that. Wish I had planned that a little bit better. Come on. There we go. All right. For number 17 and 18, they're inequalities. With inequalities, we're going to graph them just like it's an equation. So start at 3. We're going to go up 8 over 5. Now for this one, since it's equal to, it should be a solid line. There's actually only one of these that has a solid line here, but I want you to understand because I'm going through the review. So it's a solid line and we have to know where to shade. Now you can either check a point. I personally love to pick 0, 0, so that's what I plugged in, and it happened to be true. 0 is less than or equal to 3, so wherever that point is, I will shade. If it was not, if it was false, then I would shade the opposite area. Also, the trick we learned is if you keep your y on the left and your equation on the right, if it's less than or equal to, you shade below. If it's greater than or equal to, you shade above. For number 18, we had to move over, so subtract 6x. We did have some problems in class when we practiced that if we divide by a negative, we still must flip the sign. That just didn't happen in this one. We're going to start at -2. We're going to go down 6 over 1 since it's a negative. So down 6 over 1. And in this case, it's going to be a dashed line. So all of these are dashed. So I'm looking for the one that started at -2 and went down 6 over 1. So that's going to be, well, these look very similar. Actually, they look exactly the same as far as the line is. It's the shading. This one's shaded here. This one's shaded here. So let's check. I'm going to plug in 0, 0. 0, 0 happens to be here. When I plug it in, it seems that 0, 0 does work. 0 is greater than a negative number. So since 0 works and it's on this side, we're going to shade this side. Also, it's greater than, so it's shaded above, although this line is the slope is very steep, so sometimes it's hard to tell which is which. Okay, last problem. It tells me it varies directly, so we know we're going to use this formula, direct variation formula. Again, make sure you have that somewhere. They tell us these are the x and y. Similar to when we're doing the linear equations, we're going to plug in our x and y. We're going to solve for k, which is called our constant of variation. Not that you need to know that lingo. I mean, I'm putting it in your head, but I'm not asking it here. We're going to go ahead and divide by 3. We're going to get k is 5. Do not forget to write your final equation here, which is y equals 5x. That is the equation they're looking for. I did this on purpose. I made this because I want you to understand that I want you to use your work from number 19 to do 20. 20 is saying, hey, same information here. Find y when x is 9. You're going to use that equation. That's the whole point of finding the direct variation equation, to be able to utilize it to do this guy. So you're going to plug in your x is 9 here, and then we're going to 5 times 9, and we're going to get 45, because that's what y is when x is 9. And then that's it. So hopefully I've done my job and you guys are prepared for your test. If you have any further questions, please see me and let me know.